Hello everyone, I hope you are doing good. I'm really sorry that I could not give a project this Friday. I was unwell. I'm fine a little bit now. So let's go today with the same lectures, and this Friday I'm sure I'll give you a new project. So as you know, in the previous lecture or the previous video we talked about queue. I hope you got all the basic concept. I even gave a reference to this figure and how this works. I hope you got all the basic concept of queue, and in the earlier video we did with the help of an array. You know that we did queue with the help of an array, and we did not find it that good because it seems like it's obvious. But now we'll be doing using linked list. In the linked list you'll find it more easy, and you'll find it's good. You understand it better. I know there is pointers and all that you may not feel good with, but doing with linked list give you a satisfaction. So today we'll be doing using linked list. So let's just comment out all this. I'll be doing in below this so that we can compare between the two. Let's just comment out this and uncomment this. So you can see that I've done nothing, just include IOStream using namespace and this intman, and I've just written here using linked list. So today we will do using linked list, but before that I want you to see this figure one more time to know that what are the items we need. First of all, we need a node. You know that to create we need this node. We need a node. So this is the first thing that we need. We need a node. Okay. And the second thing we need this rear. And the third thing we need is the front. There is one more thing that we need. We need the connection. You know that we'll be using single linked list. So we need the next. So these are the four things that we need in our node or in our linked list so that we can get this. So let's get started with coding. Today we'll be doing with the help of an struct. I've shown both. I've done with structure, I've done with class. Today we'll do with structure so that you get one more time the idea. Why we are doing a structure is that in structure we don't need to friend function and all that because it is public in nature and it becomes easy. So let's start with struct. We'll create a struct called node. You can create it anything, but as I've said in every videos I've created with node, so that I don't want to confuse and I write it node. And we know that what we are going to insert, we'll enter some data, or we'll just call int data. And we need one more node so that we can point to the next, so we'll just write struct and next. So it's not struct next, it's struct node next. So we created one more node called next. So that is done for the node. Now we'll create the one that I said you, the let me see the figure one. So this two, we need to create this two. Now we need to create this. Okay, now let's create this. We'll create one more structure called structure of type node. We'll create first a rear, and at first we'll put it to null because we want that at the starting it should behave as null. And we'll create one more struct of type node and we'll give it name front. I've given the same name that I took in the figure so that it becomes easy to understand that what we are doing. Okay, and we'll create one more node, just temporary node, where we'll be working with, which we'll be working with. So we'll create a temporary node and we'll work with this node. This is just a temporary node, you can name it anything. So that is it. Now we need to create some function to put some data inside this node, inside this queue, and to delete and to display. First let's do inserting. We'll first do inserting. So let's create a function. We add void and the name we'll give is enqueue. So it becomes clear that what we are doing. Enqueue means to enter and dequeue means to remove. So we'll add enqueue, and now this function will do the inserting for us. So first of all we need to pass a data because we need to insert it here, this data. So we'll just write here int new data. Okay, now we need to do the functionality. What is the functionality? First we need to check our rear value. You know that the value of rear increases as the number of node increases, and the front is the first element that is entered in the node. So we'll check first if the rear is null. So we'll write if rear is equals to null, then what should we do? we'll just put the value. We'll create a new node and we'll put the value inside this. We'll write rear is equals to new node. So we created a new node in the rear because you know that every node, okay, let me show you the figure one more time. Every node we create, that is where the rear is. The rear is always the node that is created for the last time. This was created for the first, then this, then this. So if 3 was the last node created, so rear will be pointing there. So we want the rear should have pointing to the node that was recently created. So we'll write rear equal to new node and we'll put the data inside this. And we'll write rear next is equals to, why you are writing rear next equal to null? Because it is a single linked list. We are just going forward and you know the last element should always point to null and rear is always the last element that is being written. And now we need to put the data inside the rear. So we know that this is our new data. This will be the data that we will be passing. So we'll write rear data is equals to new data. Now we pass the rear, and now there is one more thing that we need to do. We need that when the first time when the rear is null, you know that, let me go to the figure one more time. When the rear is null, when the first node is inserted, suppose here we get this node, suppose here the painted with blue, for the first time rear and front will point to the same, because this will be the first element to be added. Here you can see it here. Okay, I made the figure dirty, but you know it's teaching something. So the first time when the node will be inserted, both of these will point to the same node. So we'll just write, we wrote here if rear is null. So for this condition we want that front and rear should be same. So we'll write front is equals to rear. So that's it for if the rear is null. But what if it is not null? Means it is the second node that we are passing. So for that we need to create an else statement. We'll write else and we'll put the data, and in the rear next we'll write rear next is equals to temp. That is where our this node comes to play. This will take the value of the next that the rear is pointing. When we'll do all the code, you'll understand the value of temp. Now just go with the code and we'll write temp data is equals to new data. I'll write the code first, then you can understand it one by one. I'll tell you one by one. Temp next is equals to null and rear is equals to temp. Okay, now I've written the code. Now see once, rear in the next will point to the temp. Means after the rear, suppose this is the rear, if it is not null, this is not null, if the rear is not null, and rear in the next will point to, this is suppose temp. Okay, now let's go to the code one more time. Rear in the next will point to temp. In the temp we'll enter the data that was passed, this new data, and in the next will point to null and we'll make that as the rear. Means what? Sorry, suppose in 4 there are nothing is in the 4. So if I take a color here, you'll understand in a better way. Okay, you can see, suppose we are taking with the help example of 7. Okay, in the 7 now it is null, currently it is null, and we suppose 6 is full. Okay, let's make it blue. Okay, 6 is full, so rear next is 7 is null, and we want that this should be equal to temp. This should be equal to temp, and we put the data inside here, and we'll make this rear, this temp is equals to rear. Means we'll write rear is equals to temp. That is what we are doing here. Let me show you the code one more time, you'll understand better. Rear in the next will point to the temp. Temp is that null, that is nothing is written here, and in the temp we'll put the data, the new node that we created, and in the next we'll point to null, and we want that the rear should become the temp. and that's why we'll be increasing the node. So that is the main concept of enqueuing. Now we'll do dequeuing, means deleting. So let's come down here and write deleting. I hope you got the concept of enqueue. When we'll run the code, then you can see it more clearly. So dequeue. Let's name one more function. We'll write void and we'll call it dequeue, because dequeue means to take out the number or take out the node or delete a node in the linked list. So to delete we need some condition. We want that. Now firstly let me write the code. When I'll write the code, after writing the code one by one, I'll tell you everything. First, the temp node that we created, will make it front. Why we are doing this? Because we want to free the front, but we can't free. I said you, like in the previous, when we learned about linked list, and while deleting we freed something so that we don't get the value of that. So in the similar way we are using temp, because we want that the front should stay, but the temporary value will just remove it. So we can access the access to the front to the temp. Now we'll write if front is, now suppose if there is no element, so we need to check the condition. If front is equals to null, front will be always equals to null when there are no node. So we'll write cout queue is empty, queue is empty. Okay, and you know that if the front is pointing to null, you can see here in the figure, when the front is pointing to -1, that is the null. There is nothing in the queue, means queue is totally empty. So if the queue is totally empty, then how can you delete? So we can't delete. So we'll make that if front is equals to null, then just print out that the queue is empty. Or else what if there is some node inside this? So we'll write, and we want to delete it, so we'll just write free and we'll delete the front. So whatever is in the front, we'll just delete it. So you'll understand when we run the code. Now it may seem little bit like you're not getting all the basic concept. Okay, let me just put it in the curly braces so that it becomes easy to understand. Okay, before this free we forgot to add one line. We forgot to add that line, that temp is equals to temp next. Why we wrote this? So you can see that the front will always be equals to null, even if when, suppose, let me go to the figure once again. Suppose this one was filled. Okay, there is a node here, but when we deleted for the first time, when we deleted this front will be empty. So this will be the current front. The front next will be the current front. So that's why we are adding here temp equal to temp dot next, and we are finally freeing the front. When we'll run the code, you'll see in a better way. I'm saying this again and again because there is a concept. When we run the code, everything becomes more clear. Okay, now let's do the else part. We'll just write else. Okay, let me just bring it under this. Control save this so that it becomes easy. Okay, now we'll write else. In the else, what's the condition be? In the condition, if this is not null, if front is not equals to null, if front is not equal to null means there are many nodes inside it. Now we need to delete one by one. Okay, now let's delete it. We'll just free the front. We'll free the front. Okay, we can just cut out this line from here. Okay, we'll just, okay, not cut out now. We'll cut it in the later part when we'll see there is any difficulty, and we'll write front is equals to null and rear is equals to null. Why I'm writing this line, you'll surely understand when we'll do the code. Now that's it for deleting. We'll come back to the deleting after we run the code, because when we get the result, we can compare this both. So now let's put the delete. We did the deleting. Now we need to display. We'll just say display. Now we need to display what is remained after enqueuing or dequeuing. So first of all, once more we'll write void and we'll call it display. Once more we'll give access to the temp access to the front, because we need the access to the front, because that's the one that will remain. After the front we get all the, from front to rear is the main element that remained after enqueuing or deleting. So we need to check the condition. If our front is not equals to null, front equals to null, and rear is equals to null. If both of these are null, then we know that there is nothing to display, means our queue is empty. So we'll just write cout queue is empty, and we'll just end the line. So I hope you got this line. We know that if front and rear both are null, means there is nothing inside this. And now we'll now what if there is nothing, means it is not this condition. If this condition is not fulfilled, then we'll run this while loop. While we can just return this so that it breaks. After this there is nothing getting, means we don't run the while loop if this condition is met. So we can just write here return, and you know it is a void function, so it won't return anything. So we can write this. If you write this, after this execution it will come out of this display function. So that will seem easy to understand, because we are writing a while loop, or else the while loop will also run. And we write if temp is not equals to null. Now we need a while loop that will run to temp not equals. You know this is a single linked list, so the last node will always point to null. So we want that till temp is not null, just print out all the data. Cout temp data. We want to print out the data, and we'll just end the line. Okay, now we need to print the data, and now we need to increase the value of temp also, because if the value of temp is not increased, this while will be infinite. So we'll let temp is equals to temp next. Now this temp will run until it meets the null value, and when the null value is met, this while loop will come to an end. So this is our main code. Now let's see if it is working. We may get error. There is nothing new in getting error. We get 1 or 2 error every time. So I'm always ready for error, and you should too be, because if we get error, we know that we are doing something wrong, and the next time we don't make this wrong or this mistake. So now let's call our function. First of all, we'll create a queue. We'll write cout the queue is, and we'll just end the line. So we'll write the queue. Now we know that to add element in a queue, what should we do? We call the enqueue and pass a data inside here. So we'll write insert means enqueue, and we need to pass the data. First we'll pass 1, and we'll pass 2, 3, and so on. Enqueue 2, next we'll pass enqueue 3, we'll pass 1 more or 2 more, enqueue 4, and last one enqueue 5. Now we put some element. Now let's try to display and see if we get any error. So we'll display, and let's just call it control run. Okay, our display is not getting printed, means we something mistake here. Now let's go back again and see what is the mistake we did in our display. Okay, in the display we wrote temp is equals to front. I think we should check first the enqueue, because we need to know if there is something wrong in enqueue. If rear is equals to null, this will be for the first time, because we wrote it here, rear is equals to null, rear equal to new node, and we just put some data inside this. We wrote rear equals to new node, and the data was inserted in the new data that we just wrote. Here the data is equals to new data, and front is equals to rear, correct? And else if rear is not equals to null, rear the next will point to temp. Okay, and the temp in the data will point to new data, and next will point to this. I think this is correct. or you can check it one more time. Let's check one more time. If the else condition, real next data and front rear, and in the else condition we created it. Okay, we missed one line. I think we forgot to create the temp inside this. We'll just say temp is equals to new node. So we forgot to create a new node called temporary node because we need a new node every time. Now just let's save and run this one more time. Okay, now you can see that. Okay, we did not face an error, but we forgot a line that is not going to print. We forgot the line that we need to create a new node, because every time we need to create a new node so that we can pass the data. You can see 1 2 3 4 5 is getting printed. Now what if we dequeue it? Let's try to dequeue it so that we know that our function is correct. So let's just dequeue it. Dequeue. So we need to, in the dequeue we don't need to pass any arguments, we just need to dequeue it. So we'll write dequeue once and then display it. Okay, before displaying let's write after dequeue. Okay, so that it becomes easy to understand. Cout after dequeue, and just let's run this. Control run. Okay, after dequeue the queue is empty. Means what? We just dequeued once and everything is gone. But why? Let's check it out one more time. Let's see the dequeue here. Where is our dequeue? And here is our dequeue. What is the thing we did? I think we deleted everything that was inside the queue when we call only once. So let's start from the first. We created a temporary, we gave access to the front. Then we wrote if our front is null, then just that queue is empty. But here our front was not null. So and queue is empty, and in the temporary we gave access to the next, which is the mistake I think that we did here. So again what we did here, we call the if else statement. If front is equals to null, the queue is empty. Else, okay, we need to put a braces here because we want that. Okay, let's edit it one more time. Let's just cut out from here and call it. If the front is null, the queue is empty because the front cannot be null. Else, if the front is not null, then what should be done? We need to free the temp, means we need to free the front, and the front should point to the next. So let's do one thing. Let's just cut out this and let's do one thing. We'll just edit out this code. We'll try to make it a little bit easy. If our front is not null, then what should we do? Else, do one thing. Delete this front. Okay, first we'll create one thing. We'll let temp is equals to temp next. Okay, we get the access to the temp is equals to temp next, and we'll just free out the front, and we'll write front is equals to temp. What happens in this? Let's see. This is, I just edited it, so let's save this and let's run it one more time. Okay, this was the code. I have done some mistakes in the previous one and it did not seem. This is just simple code. I just thought you right now. In the previous one it was just going in the flow. I added some more extra lines, but this is good. You can see here. Okay, let's just clear out this and run one more time. Okay, you can see the queue is 1 2 3 4 5. As we have seen here, the queue is 1 2 3 4 5. After dequeue, I already said you in queue. You can see here, first one to be deleted is the, you can see here, first input, first output, means the first element was entered is 0. So whenever we want to dequeue, first the 0 will come out of the node or the queue. So you can see here, after dequeue we deleted 1, we call dequeue 1. So the 1 is gone because 1 was the first element entered in this queue. If we write one more time, we'll call dequeue one more time. let's call dequeue and run it. You can see 2 will be gone. Okay, you can see 2 is gone. Now only 3, 4, 5 remain. So that is the main concept of queue in linked list. Let's start the code one more time so that you understand better. I think I was not clear in the first time. So let's see. We created a structure called node and we added data and next. So that is nothing new. We already know about linked list creating with structure and class. Secondly, we created this rear and front because I want to be same in the same page with the figure that I showed you. Here we have the front and rear. So I wanted to be in the same page as this. And we created a temporary node just to store the values and give access to each other. And in the enqueue, I did that if our rear is null means there is no node in the queue, then do this functionality. Else, do this. So I think you understood this. And while deleting, we check that if our front is null, you cannot delete. So we'll just print out queue is empty. Else, we'll just free out the front and we'll give the front access to this temp, which will point to the next element after the front, because you know that after deletion the front is changing. If this is deleted, front will point to this. If 1 is deleted, front will point to 2. Okay. And third, we just displayed it. We wrote that we gave access to the front and we wrote if front and rear is null. If both of these things null, you know that there is nothing in the queue, so we'll let queue is empty. We don't return because we want to return the function. After this, just break out of this function. Else, in the while loop, we wrote that till the temp is null, print out all the data and just give go temp next. Why temp is printing all the data? Because we gave the access time to the front and we know that front have access to all. And just we call the enqueue dequeue and display, and we got our queue. So that is the main concept of queue. I hope you got the basic idea. There is a lot more to go deep in it. Is very useful data structure. So that is it for today. Thank you for watching. See you in the next.